This is Algebra 2, Section 10.3, Example 3. In this video, what we are learning is we are learning the reference angle. So the reference angle for theta, it has to be an acute angle, and how it's notated, like the notation for it, it's this theta with the little apostrophe. Okay, it is formed by the terminal side of the angle and the x-axis. Now, the angle has to be in standard position. That means where its initial side is at 0 degrees and then it goes around in a positive direction. So if it's not in standard position, we will change it to a standard position. So here's rules for each of the quadrants, which we'll refer back to as we go. So let's start with this. It says, find the reference angle for 5 pi over 3. Well, just to look at a unit circle. Notice that 5 pi over 3 is right here on the unit circle. So it occurs in quadrant 4. Let's make a rough sketch. It doesn't have to be terribly nice, but just kind of what's occurring here. And so you have your axis. And so then your angle, 5 pi over 3, it's starting, let's see here, right here. And then it goes around this way in a positive direction, and it ends about here. And this is your angle of 5 pi over 3. This is in standard position. Standard position means that its initial side is at 0. It goes in a positive direction. Notice its terminal side, this is the terminal side where it ends, is in quadrant 4. So if terminal side is in quadrant 4, we're going to use these rules. Now, a lot of you will be able to do it without the rule, so I'm going to show it to you first without the rule, and then I'll show you how to use it. So just picture the unit circle. If it's 5 pi over 3, then this is 300 degrees. So picture what we had just drawn. So this was our angle right here, and it goes this way. Our reference angle is the part of the angle, and it goes from the terminal side back to the x-axis. So this right here is our reference angle. Well, if this is 300 degrees, then doesn't that mean this is 60? And how I did that in my head is I just thought, well, how many more do I need to go from 300 to 360? Or 360 minus 300. Okay, so if we go back to our other page where we had drawn it, so what we can do, it shows us this formula down here. And it says if you're in radians, to find your reference angle, take 2 pi minus your original angle. Or if you're in degrees, do 360 minus your original angle. So to find my reference angle, I take 2 pi minus theta. And so 2 pi is the same as 6 pi over 3. I did that so I'm in common denominators. And 6 pi over 3 minus 5 pi over 3 is just pi over 3. So that's my reference angle. Okay, this is negative 130 degrees. So just think where negative 130 degrees is. So keep in mind, it's going in a negative direction. So when I draw it in, it starts here, but it heads this way. So past 90, another 40 degrees it's about right here. This is negative 130. But you are not supposed to calculate it when using the angle unless it's in standard position. So notice it says theta is an angle in standard position. So it means it needs to be from 90 to 360 degrees. So think of this instead, this is the same as this angle going this way. So if I went the opposite direction, think about where I would go instead. I could add 360 to that, so I go around the other way and end up in the same place. So that would make 230 degrees. So negative 130 is in the same place, it's coterminal with 230 degrees. Remember, we did that in a previous section where we added and subtracted 360 as many times as we want. Okay, that ends up in quadrant 3. So we go look at our quadrant 3 rules, and it says, hey, your angle, what it's going to be is it's from this terminal side back to the x-axis. So when we're talking about like which one our reference angle is, it's right here from the terminal side back to the x-axis. So the formula for quadrant 3 says if your degrees, take your angle minus 180. So our angle was 230, and 230 minus 180 equals 50 degrees. So this is a 50-degree angle right here. And that's like how we can do that is we're just like, well, we went past 180, so the distance between is 50. So the key I find is knowing that when it is a reference angle, it has to be between the terminal side, meaning where the angle ends up, and the x-axis. Okay, if we go look on this, the next page, we can find this practice. This is the same thing. I just felt like we could use the practice. So picture where 210 is. So if we make a sketch of that, here's 180, but then go another 30. So 210 is right here. This is 210 degrees. So when it wants the reference angle, what it's looking for is it's looking for from the terminal side back to the x-axis. It's looking for that amount. So this is occurring in quadrant 3. And so the rule in quadrant 3 is that you can take your angle minus your 180 degrees, and you end up with 30 degrees, which makes sense because you went 30 degrees past the 180 mark. So that makes sense that that's that angle. Okay, look at this one on part B. This is negative 260 degrees. Okay, so where that ends up, you're going negative. So it ends up back here almost to negative 270. Now remember that you have to use it in standard position, so you can't have it be negative. So the first thing I'm going to do is I'm going to add 360 to it, and I get that it is at 100 degrees. So this angle is in the same place as 100 if you go this way. So it is occurring in quadrant 2, and I want the angle from its terminal side back to the x-axis. This is the reference angle. So if I look up the formulas for quadrant 2, I know that to find my reference angle, I take 180 minus the angle in standard position. And in standard position, it was 100. So it makes 80 degrees, which to me makes sense when you think about, well, this is 100, so this angle right here must be 80. All right, this one's in radians. So when we think about where this is negative. So just right off the bat, I'm going to add 2 pi. Remember, you can add 360 or 2 pi as much as you want. So if I add 2 pi, that's the same as, that is the same as adding 18 pi over 9. That's the equivalent of 2 pi. I just did common denominators. Okay, so if I do that, I get 11 pi over 9. Which, if you think about that, that is happening, it's a little past pi, because pi would be 9 pi over 9. So it's happening over here, somewhere in quadrant 3. So I can look up the rules for quadrant 3. The rules for quadrant 3 say you take your angle, keep writing Q's for quadrant. You take your angle and you subtract pi from it. So if you have 11 pi over 9 and you subtract pi, think of pi instead as 9 pi over 9. So 11 pi over 9 minus 9 pi over 9 is 2 pi over 9. And honestly, if you find it easier to convert it to degrees first and then find the reference angle, that's one trick you can do if you're struggling with the radian measure.